All right, so last time we had a set of data and we went and plotted the number of faculty in a department versus the number of credit hours taught in that department per faculty. And we wanted to take a look at this initial linear piece. And so we went through and tested for all of the departments that have the number of faculty less than 30. And so that would be these departments, mining through AOE. And then we went and so we did that as a test. Then we grabbed those rows based on that test, and then we replot it just to make sure everything is nice. And so there is our initial part. You can see it does look fairly linear. So we're going to go ahead now and fit this and get ourselves a nice fitting function. So for fitting, one of the packages that we'll use is just from SciPy Optimize, and it's called Curve Fit. So we're going to call in from that package, we're going to import Curve Fit. All right, so now to use Curve Fit, what we need to do first is to define a function for the fit. So if we want to do a linear function, for example, then I'm going to define a function called lin, and that function is going to take x values, and it's going to take a constant m for slope, and it's going to take a constant value b for the intercept. And so if I call that function and give it an x and an m and a b, then it's going to simply return that value. That's my y value for that given point. Okay, important to use return here, not print, because I need this function to return a number. I don't want to just display it. So that's as simple as it gets, and you can, whatever variables you need, you could put in here. You could use a whole bunch more if this was a long polynomial. Just define your function here. So it can be as complicated or as simple as you like. And so now once that the function is defined, then the way that we do the curve fitting is just to call curve fit. We give it that function name. Now notice here, normally when we call the function, we actually put parentheses and we give it values, 3 values in this case. Okay, curve fit's going to do that for us. So it only wants the function name. Okay. And then you give it the x values. And so these are the x values, the number of faculty. And then you give it the y values, or the result of the fit. So it's going to take these values here as input as x into this command. And it's going to then change the m and b parameters until it gets a good fit to the values here as y. That's what gets returned from that linear fit. So that's what it's going to do. And then we'll go ahead and we'll print our best fit values after it goes through this. So this curve fitting program has two outputs to it. It returns 2 values. And so when we set it up, we're going to need to tell it to expect 2 values. And the first set of values that come out are actually the values that are for the fit, so best values. And then it will give you some statistics, covariance here. All right, so I'm going to go ahead and do that. And then it's the best values that we're going to go ahead and print out here. So first make sure that we have that. All right, there we go. So my best values, it's going to simply return those for each parameter. So I have m and then I have b. So that means it's going to return 2 values in this variable best values. So the first value, which of course is indexed as 0, is my m. And then the second value, which is indexed as 1, is my b value. And then I'm just using some formatting here in this f string to tell it to give me 4 decimal. Well, actually, let's go ahead and make this, I'd rather do it this way with the 2f to be consistent. So it's going to give me 2 decimals as a floating point number. There we go. We could also just say print best values. And we could see that we get, it's a list with M and then B. All right, so let's go ahead and plot that. So to plot that, we're going to go ahead and take our slice data, number of faculty, and then with that number of faculty, so this is just these points here. Okay, that's my slice that we took, just the linear part. So it's going to take these values of in the x direction, and then it's going to put those into, notice, my function linear. Right? So I'm going to put each of those x values into my function linear, right? Same as I got here. And I'm going to pass it also the m and b I found from my best fit. So there are those values. Okay. So this is just simply going to generate now my list of y values from my fit corresponding to my x. And I'm going to make those black, and I'm going to make that a dashed line. That's the two dashes. So that's the line that gets plotted. And also on here, I'm going to go ahead and plot my original data now, not the slice, but the original data, just like we did before, as red points. And there they are. And then I'll just do plot.show, and it puts them together. So I can do multiple plot commands, and it will put them all on the same plot. So that's how we can do that, and shows my fit. All right, so let's go ahead and add a horizontal line. I don't really need it for this particular problem, but you do have to do a horizontal line in your homework, so I just thought I'd show you how to do that. We could certainly write an equation for it, just like we did with the linear case, and put in some points and do it that way. Or, so what we got here is the first two lines of code that we did here, so that reproduces this part. And then I'm going to do is just tell it to put in a horizontal line. So here's the command for the horizontal line. You just tell it the y value for the horizontal line, what the line width needs to be, what color you like, and what style. So a single dash is solid, and the two dashes is dashed. And then in this case, I'm also specifying the axes. So I'm going to go from 10 to 90. So maybe in this case I don't need to go to 90, maybe 70 would be better. So let's put that in there at 70. Let me double check. Did I actually run this? Yeah, I did. Okay. So we'll go to 70 instead. And the 50 to 400 looks pretty good. So x min, x max, y min, and y max. That's the format for that list. And then I'll show it all together. So there we go. All right. So play around with the line width and the color, and see what happens when you do that. All right. So we've got our plotting. We've got our curve fitting. Next thing we might want to do is to take our data now that we have and save it, so we don't have to reanalyze our original data set. So what we're going to do is I'm going to grab exactly which data I want to save. So rather than saving all of this, I'm taking a subset. I just want to save the number of faculty and the credit per faculty. So the way we can slice this one, since we're going to be slicing certain columns out, and including all the rows, I'm using a more general way of slicing data frames than we've done before. And so we're going to take our data, and this .loc is a way of slicing. And what it asks for is your rows, and a colon just means all rows. But I could put in here, like, let's say we want to go just from 0 to 4. Okay. So that would take 0 to 4 rows, and it would also grab whatever column lists I put in here. So number of faculty, credit faculty. So it wants rows and then columns. If I want all rows, then the easiest way is just to simply put in a colon. Okay. I could have done 0 colon. That would work. That would allow you to do something like go from row 4 all the way to the end. Okay. So there's a lot of different things you can try in here. So, all right, so that's my data I want to go ahead and save. I'll define my path just like we did before. I'm going to give it a new file for the out file. This doesn't have to exist. If it doesn't, it just creates it. And so I'm going to call this my out path. So I'm going to combine those two. And then I just take the data that you want to save. That's your data frame, this. Okay. So it's your data frame dot. Your function is called toExcel. Your path. The index equals true and header equals true. So that means that there is an index row here, and the header tells it that there's a header row. So when we go ahead and output that, this is what we get in my Excel. So you can go ahead and play with changing these to false and see what you get as an output. See what difference there is for that command. But there's my Excel file, and now I've got my data saved. That's as simple as that is. All right, I'm going to go ahead and pause, and we'll come back and take a look at this part 2.